This is day 65 review for the rock and mineral test. We are on the third page, starting off with question 18. At the top of the page here, we have a situation described to us. Minnie Earl needed to identify a mysterious mineral construction workers found while building Grant's Library Edition. After receiving the purple mineral, she rubbed it against a white ceramic plate. The purple mineral left a pink powder on the white tile. Then the sample was examined in the light. It was shiny like glass. When she masked the sample, the balance read this. After adding the sample to 12 milliliters of water, the graduated cylinder read this. This is a cylinder before adding the sample, and this is a cylinder after adding the sample. We have the two water levels. Question number 18. What is the mass of the sample? To find that, we look up here, and we look to see where the 3 pointers are, and we just add up those numbers. So we have, let's write it off to the side here, 40 plus 100 plus 2. And we add that up, and we get 142. So down here, the answer is going to be, egads, it's not written. So I'm going to add it right here, 142. Option E. Number 19. What is the volume of the sample? To figure that out, we look at the cylinders, the graduated cylinders, without any rock inside. The water level is right here, and we can see here's 10, and we have lots of individual markings here. We have 10 markings going up to 20, so each one of these markings represents 1 milliliter. So this then has a water level of 12. You read the bottom of the swoopy surface. That'll be 12. Over here, the bottom of the swoopy surface is at 10, 11, 12, 13, 14, 15, 16. Okay, so to find the volume of the rock that we've put in there, we subtract the high level minus the low level. So it's 16 minus 12 gives us 4. The answer down here is option A, 4. Please make sure that you have these markings on your paper. You'll be checked to have all of those markings in order to receive credit for taking these notes. Next page. What is the density of the sample? So off to the side here, please write mass divided by volume. The mass we said was 142, and the volume we said was 4. So with a calculator, when we divide that out, we get 35.5. That will be option A. Number 21. What is the mineral's streak? Looking back at our story, it says that the purple mineral left a pink powder on the white tile. So the pink is the color of the streak. Would you please put an arrow to the word pink and put color on tile? That's what the streak is. It's the color when you rub it on the tile. Number 22, what's the mineral's luster? Again, looking back at the story problem, it says that it was shiny like glass. It doesn't say anything here about having speckles of silver, speckles of gold, or having the whole appearance of being a big chunk of silver or gold, so it is not going to be metallic. Since it was described as being glassy in appearance, that means that it is non-metallic. Please write the word glassy there and circle non-metallic. Okay, next, a little bit more story. The researcher tried to scratch the mineral. She couldn't scratch the mineral with her fingernail or with a copper penny. However, a piece of glass and a steel nail could scratch it. So in our little diagram here, I want you to put no next to these two, and then put yes next to the bottom two. The hardness of the mineral is going to be between the no's and the yeses. It's going to be between these two. So that means that it's between 3.5 and 5.5. So that means it's option C. Please have these no's and yeses written off to the side. Number 24, use the table to determine the name of the mineral. So looking down here, let's circle the qualities that our mineral has. The color is purple. The shininess is non-metallic. The powder color is pink. The density was right around 35. And the hardness is between 3.5 and 5.5, so it could be either one of these or even that bottom one. So we have lots of different qualities that it all matches. We want the name of the rock or mineral that has all of these qualities. And so that's the first row here is all circled. So this is the name of it. Grantaz, option A. So pick the row that has all the right qualities. Next page. Fill in the boxes of the rock cycle. So these are all the different ways that rocks can change. We start off with magma here, and if we cool that magma, it will turn into rocks here, and the kind of rock is going to be igneous. Those igneous rocks can have several different things happen to it. One is it could melt and get back into magma. Melting is already written for you. Another thing that could happen to igneous rock is that it could be weathered. Weathered means broken down by water, wind, ice, and other kind of processes. And when it breaks down, it turns into sediments. These sediments can be turned into rocks. That would happen by compaction and cementation. Compaction, remember, means pressing. And cementation is sort of like gluing. So you have to have just the right processes, the right kind of environment for sediments to turn into rock. But when they do, it turns into a rock called sedimentary rock. Now, several different things can happen to sedimentary rocks. One is it can turn back into sediments by the process of weathering. Or sedimentary rocks can turn into different kinds of rocks by the process of extreme heat and pressure. If you put them under extreme heat and pressure, it turns into metamorphic rock. It doesn't melt, but it just gets really hot. It sort of like cooks it. I can think of the ending of the word metamorphic and cooks, both having the hard C or K sound. That kind of goes along. So whenever you see extreme heating and extreme pressure, that's cooking something to be metamorphic. Okay, these metamorphic rocks can change in different ways. For instance, it can turn back into sediments by the process of weathering. That means wind, rain, ice, other kinds of things can turn metamorphic rocks into the tiny sediments like sand and pebbles and things like that. Another thing that can happen to metamorphic rock is that it can turn back into magma, and that happens by extreme heat. This heat is hotter than the heat before that turned it into metamorphic rock. This is even hotter than over here. Okay, now we have another box that's blank. That is between igneous and metamorphic, with the arrow going down to metamorphic. So this box is asking us what process turns igneous rocks into metamorphic rocks. And that's the same process that turns sedimentary rocks into metamorphic. It's the extreme heat and pressure. So that is a fairly complete rock cycle. Please remember that not all of these things are always seen in nature. Some of these steps in rock cycles are theoretical. They have not been seen, but they are our best guess as to what goes on. Number 31. What happens to metamorphic rocks that are exposed to extremely high pressures deep in the earth? Now, normally when I see extreme high temperatures or extreme heat, I think that the rock is being cooked and it's going to be metamorphic rock. But none of the options here are metamorphic. So what else could it be? If I had metamorphic here as a possibility, I would have chosen it, but it's not here. So what else could happen if you have extreme high temperatures on a rock? Well, it turns into a liquid. But unfortunately, I have two different kinds of liquid here in my options. So I have to tell the difference by the fact that this is deep in the earth. So magma is the liquid underground. Magma is liquid rock under the ground. If it said that it was extremely high temperatures at the surface of the earth, then I would have chosen lava. Number 32. What happens to sedimentary rocks that are exposed to weathering and erosion? Okay, the key here is weathering. Weathering is the breaking down of large rocks into smaller pieces. And so, let's see, smaller pieces, smaller pieces, smaller pieces. Sediments are very small chunks of things like sand and pebbles and dirt and clay. So I'm going to choose option D. Off to the side here, please put weathering equals breaking down in small pieces. Next, number 33. What happens to intrusive igneous rocks that are exposed to extreme heat and pressure? Please underline extreme heat and pressure. Underline it several times. Whenever you see that phrase, you know that it's going to be metamorphic rock. Option A. Extreme heat and pressure is another way of saying that you're cooking the rocks. It has the hard K sounds in there, and metamorphic has the hard K sound at the end. Okay, I'm going to stop the video there and start up a third one to finish up this packet. So please start up the third video right away.